Hello and welcome. In this video, we're going to focus on classifying triangles. Our objectives are that we can classify triangles by their angles and by their side lengths, and that we can use the triangle sum theorem and exterior angle theorem. So let's go ahead and jump in. So let's start with how we can classify a triangle. We know that a triangle is a figure that has three sides, but depending on how those three sides are, we have different words to describe them. So a scalene triangle is a triangle that has no equal sides. All their side lengths are different. An isosceles triangle is a triangle that has two congruent sides. And an equilateral triangle is a triangle that has three congruent sides. So no congruent sides is scalene, two congruent sides is isosceles, three congruent sides is equilateral. We can also classify our triangles by their angles. So an acute triangle is going to be a triangle, a cute little triangle, a triangle that has three acute angles. A right triangle is going to be a triangle that has one right angle, so one 90-degree angle. Acute angles are less than 90 degrees, so an acute triangle has three angles less than 90. A right triangle has one angle that is right. An obtuse triangle is going to have one angle that is obtuse. So one angle that is greater than 90. And an equilateral triangle is going to have three congruent angles. Is called an equilateral triangle. So now that we have re-identified these words that we have seen in previous classes, let's go ahead and look at how we're going to add a new layer to this in geometry. All right, so we're going to first talk about interior and exterior angles. Interior angles are angles that are inside a figure, so the angles inside a triangle, and exterior angles are angles that are on the exterior or the outside of a triangle or any polygon, any figure with sides like these. It's easiest to see the difference between the interior and exterior angles if we think about extending the sides of the triangle to go further. So what's inside the shape versus what's outside the shape being formed by the lines. Isosceles triangles have some special properties. So we already know by definition that an isosceles triangle is a triangle that has two equal sides. We call those the legs, the sides that are the same. The side that's not the same is called the base, and the angles above that side, the angles that are connected to the base, are called the base angles. So the base angles are connected to the base. The other angle is called the vertex angle, and we call that top point the vertex. So an isosceles triangle has two base angles, two legs that are the same, the base, which touches the base angles, and the vertex angle, which is on the vertex along the top. So now that we've established some vocabulary, let's go ahead and look at some theorems. All right, so some of these theorems are going to sound familiar, theorems that you already maybe didn't know by name but have been using, and some of them are going to look very different. So we want to make sure we talk about each of them. The Triangle Sum Theorem says that all of the angles within a triangle, all of the interior angles, add up to be 180. So all of the angles inside a triangle add to be 180. So in this figure over here to the right, angle A plus angle B plus angle C, the measure of all of those angles adds to be 180 degrees. The exterior angles theorem says if we're talking about the angle on the outside, an angle on the outside, that angle is actually equal to the sum of the two angles it's not touching. And remember, that word for not touching is non-adjacent, non-adjacent. So the measure of the exterior angle is the sum of the two non-adjacent angles. And this really should make sense because angle 1 here would make a linear pair with this angle over here, and these three angles have to add to be 180. So it does make sense that 1 is the same thing as angle A plus angle B. The corollary to the triangle sum theorem is specific to right triangles. So if we know that we have a right angle, since all the angles add up to be 180, this is 90, that means that angle A and angle B must add to be 90. Since C is already 90, really we're just taking this theorem and we're substituting in 90 for one of those angles and then subtracting 90 on both sides. That's where this corollary comes from. These next two theorems are specific to isosceles triangles. So let's go ahead and write the word isosceles there. Isosceles. And it's in there as well. But the base angles theorem says if two sides of a triangle are congruent, so if we have an isosceles triangle, then the base angles are also congruent. So if AB is congruent to AC, then B is congruent to C. So if we have an isosceles triangle, then the base angles are congruent. And actually, let's write that, base angles congruent. The other theorem is the converse of that. So we're saying if the base angles are congruent, then it must be isosceles. So if base angles are congruent, then we must have an isosceles triangle. So these bottom two theorems are specific to isosceles triangles. The corollary to the triangle sum theorem is obviously specific to a right triangle, but the other theorems, the triangle sum theorem and the exterior angle theorem, apply to all types of triangles. So now that we've established our vocabulary and laid down some theorems, let's go ahead and look at some examples. All right, on our first example, we are going to plot the points to create the vertices, the endpoints of the triangle, and then we're going to classify the triangle by sides and angles. So go ahead and pause the video to plot those points and connect them, and then unpause the video and we'll talk about the classification together. All right, here we have our triangle. In order to classify by sides and by angles, we need to figure out what the length of each of these sides is. So if we look at the length of BC, we can actually just count to find that length. So BC is 1, 2, 3, 4, 5, 6. BC is 6. For CA, we can think about the distance formula or drawing this right triangle. CA, or I'm going to call it AC, is going to be the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, or the square root of 18. We know that 18 is 9 times 2, so AC is going to be 3 root 2. And then we can look at BA, or AB. That looks like it's going, oh, this actually looks like it's going to be the same as what we just did. So instead of re-showing all that work, I'm going to just jump to the conclusion, which is it's going to be 3 root 2. So if we're classifying this by sides, we have two sides that are the same length and a third side that is not. So this is an isosceles triangle. So let's say triangle ABC is. And then if we classify it by angles, we need to figure out, looking at it, it looks like it's either an acute triangle or a right triangle. In order to talk about classifying it by sides, we need to see what's happening here at angle A. So we could do that. If it's a right angle, that means those segments would be perpendicular. So let's look at their slopes. So let's find the slope of AB, which it looks like is up 3 over 3, up 3 over 3, which would be a slope of 1. And AC, slope of AC would be down 3, or CA, down 3 over 3, down 3 over 3. So AB is actually perpendicular to AC since their slopes multiply to be -1, which means that angle A is a right angle, which means we have an isosceles right triangle. Triangle ABC is an isosceles right triangle. So we have classified it by sides and angles. Let's look at another example. All right, for number 2, we have an exterior angle, and the exterior angle theorem says that this angle is going to be equal to the sum of the two angles that it's not touching, that it's not adjacent to. So that's going to equal x plus 70. In order to identify any of these angles we're being asked about, we're going to need to first find the value of x. So let's go ahead and solve for x. If we subtract x on both sides here, that's going to give us x minus 5 equals 70. If we add 5 to both sides, that's going to give us that x is equal to 75. So this is using that exterior angles theorem. X is equal to 75, and x is also what the measure of angle J is. So the measure of angle J is x, which means the measure of angle J is 75 degrees. Don't forget that measure of angle, and don't forget that degree symbol. Now, in order to find the measure of angle K, which, let's actually rewrite this, JKL. I think that's a better way to word that. And there's a couple of ways that we can find the measure of angle JKL. We could either use the fact that we found x, and if we know what x is, we can find the measure of angle JKM, and then subtract that from 180 because this is a linear pair. Or we can use the triangle sum theorem and say that the measure of angle J plus the measure of angle L plus the measure of angle JKL is going to equal 180. And we know that angle J is x and angle L is 70. So let's go ahead and write x plus 70 plus the measure of angle JKL is going to equal 180 degrees. That's using the triangle sum theorem. Then we can substitute in that we know that x is 75. And we can combine like terms. 75 and 70 is going to be 155 plus the measure of angle JKL equals 180. And we can subtract 155 from both sides to get that the measure of angle JKL is going to be equal to 35 degrees. Now, to find the measure of angle JKM, this exterior angle that we already identified, we can simply plug in x, or we could do 180 minus the 35 that we just found, since this is a linear pair, or we could say that the measure of angle JKM is equal to the sum of these two angles, which is what we started with. So lots of options here. It seems like the easiest math for me is going to be to add the two exterior angles, which we actually already did on part B. So the measure of angle JKM is 75 plus 70. So the measure of angle JKM is going to equal 155 degrees. So knowing things from other chapters is still benefiting me. Knowing about linear pairs is helping me be able to use and have different options in how to solve these problems. Let's go ahead and look at some more examples. All right, for number 3, we're going to find the value of x, and then we're going to classify the triangle by angles. I'm going to encourage you to pause the video, work through this on your own, and then unpause the video and see how you did. All right, well, first of all, we could use the corollary to the triangle sum theorem to say, since this is a right angle, which, by the way, is how we could classify this by angles, this is a right triangle, we can add these three angles to get 180. So 2x plus x plus the 90-degree angle is 180. That would just be using the triangle sum theorem. But what the corollary to that theorem says is if we have a right triangle, then I can actually just add these two angles to get 90, which is the remaining amount of degrees. So we can combine like terms to get 3x is 90. We can divide both sides by 3 to get that x is equal to 30 degrees. And there we have it. Let's look at another example. All right, both of these problems look like the two that we just did, so I'm going to encourage you to pause the video and take a shot at them on your own, and then unpause the video and see how you did. All right, hopefully you had time to work through these on your own, and if not, you can always pause now. We have an exterior angle that's going to equal the sum of the two non-touching, non-adjacent angles. So 5x minus 10 is going to equal 3x plus 40. If I subtract 3x on both sides, I'm going to get 2x minus 10 is 40. If I add 10 on both sides, 2x is 50, and x is equal to 25. Now, we weren't asked to find x, we're asked to find the measure of angle 1. So if we add these three angles together, we should get 180. So we can say 40 plus 3x, which we know x is 25, plus the measure of angle 1 is equal to 180 degrees. 3 times 25 is 75. 75 and 140 is going to be 115. And if I subtract 115 from 180, I am going to get 65 degrees. And there we have it. For number 5, these two angles are going to add to be 90. So 2x plus x minus 6 is going to add to be 90. So 3x, if I combine like terms, and also I'm going to add 6, 3x is going to give me 96. If I divide both sides by 3, I'm going to get that x is equal to 32. Now this question is asking us for both acute angles. So the acute angles are 2 times 32, which is 64, so 64 degrees, and 32 minus 6, which is 26 degrees. And there we have it. Let's look at 2 slightly more complicated examples and then go ahead and wrap up this video. All right, for number 6, it says, given the triangle below is equiangular, meaning all of the angles are equal, find the value of x. Well, if all of the angles are equal, then all of these angles are 2x. So I can say that 2x plus 2x plus 2x is going to equal 180 degrees, which means that 6x is going to equal 180 degrees, which means that x is going to be equal to 30. Now, for number 7, this is kind of a puzzle. So what I want you to do is I want you to pause the video and just take a look, see if you can identify anything interesting about the types of triangles that we have. If you notice anything helpful, you can take a run with it. Otherwise, afterwards, you can unpause the video and we can work through this last question together. Okay, so the very first thing that I noticed is that I have an isosceles triangle, and one of the theorems we learned today says that the base angles are congruent. So I can actually find the value of x because x plus 40 makes a triangle, which means it adds to be 180 degrees. I can combine like terms and subtract 40, so 2x is going to equal 40, so x is going to be equal to 70. The value of x is 70. Now that I know that, I can come over here and I can change this to say 70 minus y. The next thing I notice about these triangles is that this triangle is an equilateral triangle, which means all the sides are the same, which means this side is the same as this side. And after I plug in that I know x is 70, I can say 2y plus 10 equals 70 minus y. I can add y to both sides to get 3y plus 10 is 70. I can subtract 10 to get 3y is 60. And I can divide by 3 to get that y is 20. So I love problems like number 7 because they're sort of like puzzles and you have to just kind of pick through and figure out what you know and add things to your diagram to help you figure out what you need to figure out. Let's go ahead and wrap up this video. All right, 6.1 was about classifying triangles both by sides and by angles. We reviewed vocabulary like equilateral, equiangular, right triangle, scaling, isosceles, acute triangles, obtuse triangles, and then we used those facts to solve for various values of x in examples. We also used the Triangle Sum Theorem and the exterior angle theorem to be able to talk about relationships between angles within triangles. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.